Hello and welcome. I'm Bill Wake. We're working on a program to compare tunes for similarity. We're working in Swift, and we've come a fair ways. We've got a report that does a parsons code analysis, which captures the shape of a melody. And we're trying to break up the system a little differently so we can substitute different analyses and different things in the pipeline. And I don't know, we're kind of in the middle of it. I'm not quite sure how it's going yet. Let's see. So I think we'll run it for starters here. Okay, so this view shows all the stages that happen. So you can input some text. You run the quantizer optionally that kind of regularizes the rhythm. You can generate a Parsons code report, and then you can view the report. All this is visual. The real code doesn't look like this. It's not 4 stages of a pipeline. It's somewhere in here, the generate report button has the actions to make all these things do their thing. I'm trying to move away from that, but we'll see how it goes. Okay. One thing, make quantizer transform apply its rules to packet and call it out. Yeah. So the way quantizer works now, it doesn't do any transformations. It really, well, all the work happens in the Parsons code view. So in here's the method that gets called. So it starts off with a packet. It passes it through text input source, and then it doesn't do anything with it to quantizer. But we do create a quantizer and then apply it. Yeah, this is weird, I think. But we use that to, we basically pull the data off of that view that we have with the 1/4, say. That's the numerator denominator. If this thing is active, we build a quantizer, and let's go look at that. Okay. So the quantizer, like I don't even know why this is in their Parsons code report, right? It basically transforms a rhythm. Let's see. So what's it getting to? Basically, you give it the rhythm, and it produces a transformation function. Okay, that converts one measure to another measure, and then that gets applied in here. Here it's doing measure transform. I mean, source.transform is the Parsons code transformation. Let's see that one. That one really it delegates everything to the Parsons code report. But it creates a packet with the title and the output of the report. So it does the transformation that way. Quantizer transform is just being, it's being ignored. It uses this to get the right color and names and stuff, but that's it. Okay. Sorry, my voice has really been rough lately. All right, so what I was hoping to do was pull that quantizer stuff in here. And, I think what I can do instead, I don't know if this is better or not. Let's look at packet. Okay, so packet is our thing that holds all the inputs and outputs that go on in these transformations. So if you're transforming a tune to another tune, that's fine. Or you can pass through a function that does measure transforms and so on. I think these could be combined. I think we could make our our tunes. How are we going to do that? Well, in a way, I could say make tunes be. Now, how do I want to say this? I want to take a measure tunes. A measure transform, which is a measure to measure function, and I want to apply it to a tune and get a new tune, and then build up the list of those. So the notion would be it applies that transform in the tune itself. Okay, let's open tune. All right. So tune, the big thing is you ask for a measure, you get the measure. But I could imagine somebody who says, I'm a transforming tune, and you give me a base tune and a transforming function, and I will convert your measure to the new thing. Okay. I think this could go away. All right. So I don't know. I feel like, what's the best way to get things moving? Where's my Parsons code view again? I really hate these temporarily open ones. It's like, just let me keep them. I open them because I want them open. All right. So I guess I could either tackle the quantizer. That would be reasonable. I don't know. I'm uncertain about a number of things. One is like, who owns this state? Right now, that's maintained in the content view, which is the overarching state of this thing. It really seems like it ought to be owned by the quantizer, whatever piece of the pipeline that is. Now, how to get the variables in and out to that, and whether that makes sense, I don't know. Also, we have this error. That's on text input view. And I kind of skipped over it yesterday, but I'm being more and more annoyed. Somewhere I thought I made a warning out of that. Let's build. No. Okay, so here we've put the binding on the input string. Let's see, maybe content views where, oh yeah, there's that purple. Okay, where are you? Yep, content view. Accessing states view outside of being installed on a view. I think its complaint is that text input source is not a view, which maybe tells me I'm not. Maybe I'm supposed to make these more observable objects than states. I'm not sure. So I'm inclined to let this problem simmer a bit, although I'm more worried about it today than I was yesterday. But I think I want to let this simmer a bit and work on kind of cleaning up the model side of things. This quantizer passing a separate measure function that keeps living around, and we have to remember to apply it. It just seems like more than we should ask our thing to do. Okay. So, all right, let's, So what would happen is you give me a tune, and if I'm a measure updating tune, I guess you're going to give me a function, and I'm going to use that to update the measures. Okay. So let's see. Notes. Right. So he fetches measure off of parts. Symbols. I think that gets the symbols out of a measure, if I remember. Yeah, measures contain meter and symbols. Okay. Right. Oops. Okay, so I'm going to create a tune that takes a tune and a function. All right. And I don't know, this is kind of a refactoring. It's nothing like you're going to find in Martin's catalog or anything like that, but we're not adding new functionality. We're kind of trying to change where this measure function gets applied. And I think the better way to do it is to take it off on measure. Okay. Get some code here. So this is domain. All right. So let's start with a test. New file. All right. So what we're doing is I don't know, measure map tune. We'll start there. Oops. Oh, you're not the one I wanted. Where did my test go? That's what I'm trying to do. Okay. So measure map tune. All right. So I guess so tune, let's see, how do we create it? We give it metadata and parts. Okay, I guess the first thing I could check is that the metadata is not altered. All right. We want to put something in that. Well, I assume we're going to have some that create some tunes. Tune does. Okay, it's being done without. I guess I gotta look at Tune Builder to understand that. Okay, just get the names. All right, so I can put title in. Okay. Well, I need to create a tune first. Maybe that's why they did this. Tune Builder. Yeah, I can just use this. I think I can just use the ones I want. Titles. Okay, measure map tune of tune, and for now it's quantizer.none. I will do better later. Okay, so we created a tune, we created a map tune from it, and we want to make sure tune, make sure I can get the metadata. Index of string gets the metadata. Okay, so if I say tune subtitle, I expect to get original title. And the test is map, measure map tune retains original metadata. Okay, this thing doesn't exist. Now, I think we'll make this an extension. I don't usually do it that way. I need to put a protocol in here somewhere instead, I think, but let's get it working first. Okay, so this is a class. Okay, it's got a constructor takes a tune and a quantizer. Oh, we had a name for this thing. Measure transform. I'm gonna pull this. Trying to find the right home for that. Okay. This is where I don't really want to be. Okay. Let's Let's pause. I'm going to say public protocol. Oh, let's rename tune. This is the tune with all its right information. It's like a bass tune or simple tune, bass tune. Concrete tune. All right, let's do bass. Okay, I think, let's see who's modified here. All right, I want these to all be tune. I think doing this will tell me what tune has to be. That will go away. Yep. Tune builder. Makes a tune. It's fine that it returns a bass tune, but most things want just tune. That's the way I'm conceiving of it. Okay. Now we're going to get some errors. Code 4, let's see that. Tune. Bass tune. Who wants bass tune? Okay, yeah, this is one. Any tune has no member notes, so we need to pull notes up to tune's parent. Okay, notes. This is measure transform. I think we don't need. Document not permitted. Okay. Do we need? We don't need public. Okay. Yeah. Defaults to it. Okay. And I can't believe this is the only place that's not working from that, but let's do a build. So I'm trying to split up Tune into base Tune plus a Tune protocol. And anybody who uses Tune is going to go through the protocol. I got to think there's more than notes going on because people got to look at that metadata for some reason. Maybe they don't. No, the Parsons Code report must. Okay, so let's see if there's any base Tune in here. Report takes a Tune. Tune title. Okay, yeah. So there's no subscript accessor yet. Subscript. You would think somebody would want part as well. I think that is just a get. Tune has no subscripts. I think he's catching up. Okay. Base Tune does not conform to Tune. How is that possible? Base Tune does not conform to Tune. Oh, because I didn't say that yet. I assume that error will go. Okay. Expected. Okay, this has to be a Tune. I don't really need it at all. The declaration part of this. I think it's fairly obvious. Oh, he's got to be equatable. Yeah. I don't think that's actually right. Protocol tune as a type must be written any tune. I don't see why I'm passing tune. Type any tune to expect. Oh dear. Okay. I may be fighting my way backwards on this. Where's tune? Okay. Maybe working out different. Note, this is optional. This thing seems to implement it even with this optional thing. Who's complaining about that one? Equatable. Okay, measure. Yeah, that one seems like it should be in tune as well. Okay, I'm going to rename this file for the parent type. Yeah, I wondered about that. Huh. Okay. Any tune cannot conform to equatable. I don't know why he's any tune. Okay, parse tune and tune builder. Let's make sure they both produce tune. Yeah, he's not going to let me compare to any tunes because that's just, they're potentially totally weird types. I don't know if I'm recovering from this or not. Missing argument. Now that is weird. Those might be well served by being explicit, but I want it to go away is what I really want. Okay, let's revert that. Taking 2 tries. Let me commit the to do and the 10 sim button. Revert the rest. Okay, and now let's revert all these. Okay. All right, let's look at tune again. He's got measure. The problem is notes has to call map inside it. All right, I don't know if it would be better, but I could make this explicit every time that you pass this in. Okay, this is a measure transform. Okay, what would be the benefit there if you move this to tune? Okay. If I made it explicit, what would that do? It would make all the callers that use it call it out. But I really want to get it out of there completely. And I want to make it so that there's a new class that goes through and gets the measure and does its own mapping. And it should apply the map function. Well, one thing I could do, I could say there's a map function. Maybe that would be, let's move it to the constructor of the tune. Is that right? No. It really isn't, because we don't know what the caller may want to do something. Like if they want to quantize, they'd have to know it at that moment. But maybe that's okay. Right, let's see what happens if we put that in. Okay, because anybody who calls notes without a map function doesn't need it. Okay, so let's add that. Will be a tune test. Oh, I didn't revert them, did I? Okay. Make sure. Protocol. I'm missing something. Sorry, let's clean. I don't think it's very good about recognizing when it needs to flush everything. All right. Okay, now I can create a tune test. Oh, I think I want to do the tune builder thing. Yeah. Okay, event dot rest rhythm 1 1. Okay. Reference number events. We get a tune. Oh, how are we going to get the transform on there? Oh, I can't get it back out. Yeah, let's do that. Let tune 2 equal tune with tune and the function we want. Okay, so let's see a transform. I guess let's see what measure looks like. Okay, so we can put our own measure on that. Okay, so we're going to ignore the measure we get, and we're going to rewrite it with measure meter is rhythm 3 4, and the symbols are event dot note 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 C. Measure that. Okay, he hates everything about it. Cannot convert rhythm. Oh, I guess that's true. Meter is different. Okay, let's just make it meter.common. Okay, we don't have this constructor yet, so it should complain. All right, where's tune? Okay, so if we say public init tune of tune and measure map of measure transform. So that's an identity transform. And we're going to say self dot metadata equals tune dot metadata. Self dot parts equals tune dot parts. Self dot measure map equals measure map. Okay, I think okay. Where's my tune tests? They get separated. All right. Maybe I can split. Okay. Tune maps measure with supply transform. Okay, so we take a tune measure map. I think I call it measure transform. No, I call it measure map. Okay. Cannot convert value of type event to expected symbol. Array symbol. Yeah, these are symbols. And I think symbol has a note. Yeah. Okay. All right. I think this will pass. Oh, well, it certainly will without an assertions. So we want to assert that tune2.measure index 0 a part, well, that's kind of implicit, should be this. Have I got too many parens? No. Okay. I guess we can make this. Let's do this and ignore measure map, and that should make the test fail. Okay, and the failure should be it's getting a rest instead of a note. Measure free gets a rest instead of becoming that. Okay, and this should be like that. Well, oh, we don't apply it. Okay, yeah, we have it, but we don't use it. All right. If empty, I think we're going to say you don't transform empty measures. Let's return, what do we call it? Measure map of this. Oh no, we really have to do it every case, I think. Well, maybe not. It doesn't really make sense to have empty measures anyway, so I think we're okay like that. All right, and this should do its job now because it's applying the measure map. All right, and everybody else should be neutral to it. Good. Okay. Provide a tune constructor that has a measure map. Use it in measure. That feels better. Okay, now I want to find everybody who uses this. Okay, so anybody who uses notes by itself, I'm actually good with. So I guess I want to do this temporarily. Build this, and I should see all the places. Okay, I want to find all the places that relied on it. It's just the one. Okay. Right. So here we could make tune with tune and quantizer, right? And then do notes without the quantizer. So it's part of the tune, not part of the notes. Okay. To get the chain of quantizer escapings. Okay, that built. That should work. Hey, Schooly B, welcome. All right. So we're working on this program to compare tunes for similarity. And one of the things that happens is you can take a tune and say, I just want to compare on the quarter notes, at a certain rhythm. And then all the extra notes get left out. And I put that in a less than ideal place, and I'm moving it around now. So that's what we're in the middle of. I'll run the app in just a minute, and you'll see what's up with that. But I kind of, before I forget what I'm doing here, I'm going to take this out, measure, and okay, so I think we're just going to get the symbols here. Is that map? Okay. And that one's there. Kind of keep my thoughts together before I move off. Okay, measure map. Okay, so the measure map gets applied in the measure. That's what we want. All right, everything's running. Okay, so make measure map part of tune, apply it in measure, and callers who previously passed it to note may instead make a tune with a measure map. Okay, let's run this thing. Okay, we'll open NOS. So this format here is it's called ABC. It's a text-based format for musical notation. And at the bottom here, you can see this is like the note. So C, B, A, G, F, G with bar lines and stuff like that written in. There's a lot of other mechanism, but the essence of it is this little stretch of notes. And what I've got is 39 variants of a tune called No Scalin', which is really Deck the Halls, the Christmas song, if you know that one. It was originally more of, I think, a Welsh New Year's tune rather than a Christmas tune, but it kind of evolved. So I've got all these variants that Fiona Potts collected, and I won't quantize. I'll just generate the report. Okay, and this should scroll back, but it's not doing it for some reason. Okay. This shows the tunes. So what it's done is it's encoded them with this little DDRU stuff that says, are you going down, 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 repeat, up, down, up, up, up. So even if it's jumping by different amounts, two tunes would look like the same graph on this. But I take these variants and I'm sorting by this, I think. But you can see the first two are very similar, maybe even identical. The second two are pretty similar. They kind of look like the middle of this one. This looks more like the original, but it doesn't have that underbar stuff here. Again, similar, but then, whoa, this is very different. And then, oh my, this is very, very different. So, it's not going da 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 da. It's going da 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 da, whatever. But we get different melodies, even though it's supposedly the same tune. We see all these variants, and that's what this code is giving us. I'm comparing the variants to each other. So each one gets encoded like this. Are you going up, 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 or down, or up, down, and then we're getting a view of the graph for each one of these. The sorting is I just sorted them alphabetically by this, but that doesn't tell you, like, it could be the first two notes are different and everything else is the same. That won't bring them together in this sort. I'd have to do some sort of more clustery kind of thing. But I can see that there are variants that are somewhat similar, like these two, and then this one's very different. And, this up, down stuff shows up here and it shows up here. I can see little similarities and things like that. And so that would help me when I could go to the music and really dig in on this part and see, are they really kind of the same, or how come these other variants don't have it? Okay, so it's some sort of like a musicologist might want to do this kind of analysis. And then the other piece of this that we have in here is this notion of quantizing. The two I have, it's like if you think of Twinkle, Twinkle, Little Star and A, B, C, D, E, F, G. When you sing A, B, C, D, E, F, G, all of a sudden in the middle you go L, M, N, O, P. And in Twinkle, Twinkle, you're just wondering what you are. So the L, M, N, O, P's got lots of notes, and it's not a fair comparison. So quantize cuts them out and just says, let's just take a steady beat. Whatever's playing at that moment will be what I use. And it gets different results for that. Okay, I'm not sure we can see the difference, but it should be there. Okay, so I'm gonna trim this down because I'm not sure I'm quantizing or not. Oh, let's see. So the format I have to kind of like remember. NXT title, you got to put a key, and then you can put some notes. So if I put A, B, C, D, A, B, C, D, they should come out by default as eighth notes. Okay, A, B, C is down, D, A, B, C, down, D. Okay, that looks all right. If I quantize, this should change. Oh, okay, generate report. That is not changing. Okay. Let's do ABC. How about A? Okay, I'm going to turn this off. Generate the report. That should be a little different. Okay. If I quantize, there's a weird bug on this. Okay, if I quantize by quarter notes, they should be different. They're not. let's try half notes. No, there's something wrong here. The main thing is right. The quantizing is not working, and that's the thing we were just fooling with. So unfortunately, a lot of the quantizing is done. It's still up in the view more than anything, and I hate to have to go there, but we're going to. So user interface, Parsons code view. All right, so packet. Okay, this source is our Parsons code transformation. So it gets this with the quantized map. Let's see. Parson transform. Okay, so he calls report with this transform in it. Okay. Where's report? Report with this quantizer. He gets code for quantizer. That's used here, and we just modified that. So, I guess I want to see this thing running. Quantize, I'm going to break here. Let's look at the tune. Oh, I probably should have done debug description. Okay, it's got a bunch of eighth note measures. That's what I expected. The quantizer, I don't know if we can. Okay, let's see. Tune dot part zero measure. Okay, I'm gonna have to look at tune. Part subname. Gives me an array of measures. Parts of part name. Oh, maybe doesn't. Okay, so I think what's going on is we've produced these measures, but we haven't transformed them. So they go in untransformed. If you create a new one that you say we want to transform, this function returns measures, but it never called this function that does the transform. And really it needs to do it like its own map. So let's put a test in that says part must test its measure, must test its transform. So tune tests. Okay. So let's check the parts. Okay, so we got this tune. It's got a rhythm. It's supposed to transform the rhythm to a single note. And let's take tune subparts. Part A sub 0. Okay, should be a measure like that. And I think we're going to find out that it's still a rest. Yep. Okay. So tune. Then this needs to do a map of measure map. Oops. Type measure to entire type measure. Parts, part name. Okay. Part subpart name should be an array of measures. Type of this should be array of measure. Okay, so let's just return it. Well, and if don't need the word return if it's the only thing being done. All right. It should pass. Good. Okay. Let's run this. Do my same tune. X1 T title. Key of G. Let's do CC DD DD BB. Okay. If I don't quantize, that should just be that. If I quantize by a quarter, it should be half as many notes. There we go. Quantize by a half. Should be 2 notes. And quantize by 1, it should give me the first note. Star. Okay, yeah. I'm glad I had to show this off because might have missed that for a while. All right, so make sure part applies measure map. All right. I'm feeling kind of lost. I guess what I need to do is make sure anybody else in Tune. I haven't looked at it too much. I'm kind of skeptical. Kind of, I don't know, kind of like in a way you're ripping off the people who did all this stuff and, you know, stealing it for public domain when you didn't necessarily have it. And also I just wonder how much it's how well it's doing. But yeah, don't know. Have you tried it and seen it working? Okay. Well, yeah, there's benefits, I guess. I mean, okay, cool. Yeah, maybe you'll convince him to experiment with it. I worry a bit because there's all kinds of pretty bad code out there. It's like, can you take all this and somehow turn it into good code? Yeah, I don't know, but yeah, worth playing with. I worked with a group years ago. I worked on a team writing compilers, and one of our customers was a um, healthcare company writing stuff. Uh, writing their healthcare code in C for some machine control or something, and they part of their job was they would write their code and then run it and debug it and all that stuff. They would review it at the assembly code level and make sure that everything was looking like it was supposed to, that they didn't want to trust the compiler even. Understandably, I mean, every software I know that's of any size has bugs, so they don't necessarily have a lot and all that, but they did that same sort of thing. And I wonder if we're going to be in that same kind of mode, like you have to take this code that's written and then really, test the snot out of it and make sure it's what you really, really wanted. And if that's the case, then I think the kind of combinatorial tests and things like that are going to become a bigger deal. That sort of trying to automatically test things, but I don't know. It's interesting. The thing I'm learning with doing this stuff in the music domain, I've got this ABC notation that's so. I mean, I've got the spec. It's like 100 pages of, stuff to encode, and it encodes things. Some of it's for typesetting, some of it's for performance, some of it's just to get the notes. Yeah, I don't know. I mean, somewhere at some point, somebody's got to test something, or else it can't be turtles all the way down. Like, what's going to convince you about each level down further? I don't know. But yeah, maybe I'll do some experiments sometime, just see what I can get from it. What kind of program were you writing with it? Okay, so what I think we really did was we made Tune accept a measure transform and apply it to any results instead of being a separate thing. Okay. And we're December. Oh. December 1st. And okay, cool. If it comes true, I guess it'll make it your ability to write good descriptions will become very important. Well, why, use it. Just like hiring your subcontractors, I guess, right? Makes me wonder if we can create GitHub Copilot that way too, right? Okay. Let's take this. Okay, so make quantizer transform, apply its rules. Okay, I think we want to do that now. I'm going to close all this again just to kind of clean it up. So let's take quantizer transform. So right now it says the way I transform to apply quantizing is I don't do anything. Okay. We're letting somebody else kind of put that stage in. So let's make this thing do its job. And then we can simplify our pipeline a bit. All right. So we also need ParsonsCodeView because that's where it's being done now. So this code it's in our view class, even though it really is the code that's doing the work. Okay, but we don't our Parsons code, our quantizer transform doesn't know these values, so I think we're going to have to do that. So let me find the Parsons code transform. Parsons code report transform. No, text input source, that's the one. Yeah, so we have to connect it somehow to the view. And so I think we're going to do something analogous here with these numerator and denominators. So that's the transform. Okay. It'll just be a binding, a couple of bindings. And we got a warning, so I feel like we're skimming on a dangerous edge somewhere here, and I'm not sure I fully understand it. This is an int, and there's a denominator. It's an int. Okay, and there should quantize is a bool. And we'll import Swift UI, which is how I know this is a little flaky. Has no initializers. Okay, so now we have to provide an initializer to fill in these fields. There you go. Wow. Most of them I don't want. Okay, I don't want to set these fields. I guess this should be let. They're really supposed to be constant for this class. Denominator, we don't need name. Okay, any of that. Those three go away. Okay. So when you're creating one of these, you should pass in. Oh, and we have to initialize, the underscored version. Okay, bindings have an underscore version of their name that gets to it. Okay, cannot assign value of type bool. Type binding a bool. Okay, wait a minute. Oh, these are bindings on the inputs, yeah. Okay, that's all the stuff that we need for it. And then in here, well, who's creating this? I don't know if anybody is today, because it doesn't really do anything. Quantizer transform, setting view does, content view does. Okay, same deal. I'm going to have to provide the stuff to it. Okay, so I'm going to get more warnings. Okay, he's going to complain soon enough. That. Okay. Hopefully that'll take some of this out of here eventually. Okay, so we got quantize source. Okay, is quantizer. Good. Okay. All right, I think we should be okay. Oh, right. Well, let's just create this down here. All right, and then if we run, KFG and CC. How about CCAB, chain report, that looks good. Quantize 1.4, should be 2 nodes. Good. Okay, so make quantizer transform take its numerator denominator and should quantize variables. All right, we've been going a while. I think let's take a break, like 3 or 4 minutes. We'll come back and continue with quantizer transform. It still doesn't do any transforming. It just returns the packet it's given. So we'll make some modifications there. And then I think once we've got this function applying, it's actually going to modify tunes. And I think we're going to get rid of this measure transform thing. So we're going to simplify a little more. We're still a ways working our way through the jungle a bit, but that's okay. All right, so see you in 3 or 4 minutes. Hey, welcome back. All right, let's see. So we want to do the transform, and that's being done in ParsonsCodeView right now. So this logic, well, basically this logic. Okay, so I'm going to put this here. Okay, and then I want to see what's in packet is tunes. Okay, so I can make a new one if I give it an array of tunes, and I can, it's a sequence, so I can walk through it. So I think I can I think I can do the transform I need. All right, so given a packet, we want to get the tunes out. Okay, we got a map. It's either a quantizer, which we can pull this code over. Well, I think he can. Okay, so here's this quantizer function given the numerator, denominator, and so on. Okay, so we want to take packet. All right, so packet basically lets you replace pieces. Okay, so you pass in the initial packet and replace the pieces with whatever you want. So I think we're going to do that. We're going to say return. Well, let's map the tunes first. So let new tunes, mapped tunes equal. Well, let's take packet.tunes and then map them. All right, so we're going to map them. Tunes, each one is a tune. So we're going to map each one to a tune with this tune in. It's got a tune, and we're going to give it the quantize map. No. Quantizer produces a map. Okay. Missing label, yeah, okay. Good. All right, so now we've got the new tunes that we wanted. So let's return packet with the existing packet with tunes replaced by the tunes object of the mapped tunes. Okay, I think this is neutral. Tunes, sorry, let's look at tunes. Tunes, array of tunes. Okay. Yeah. Now, I don't know. This I don't think is tested now, other than because it was in GUI code and probably wasn't tested up there. Well, I'm pretty sure we haven't written any GUI tests yet. So, nor are we likely to write very many. But this, well, and I suppose what he's doing is also measure map is quantize map, but we're going to get rid of that. All right. So I think this should run. This will parent up there. That one there. Well, apparently I don't know how to parenthesize. Extra argument. Packet tunes. Oh, measure transform. I haven't been consistent. Test should pass. Okay, and we'll give it a run. Now, next one, t-test, key G. That's 8 notes. Okay, the report should have 8. If I quantize to quarter notes, it should only have 4 notes. Good. Okay. Now, we got the quantizer transform going. And let's see what ParsonsCodeView is doing. I don't think anybody's calling this anymore. Oh, well, we're still calling this code here. Okay. Text input source. Okay, now if I do packet equals quantizer dot transform packet, that should take the place of this line, this bit of code. I'll comment that out for a moment. And we want to do just packet here. Okay. Again, it's unlikely to break any tests because we didn't change anything down at that level. Just GUI. X1, TT, key G, ABCD, EFGA. By itself, 8 notes, quantizing to a quarter. 4 notes, good. Okay. Now these are much more okay. Right. Okay, so let's commit this. Use quantizer transform to do the work when button is clicked. All right, now this should be dead code. Yep. Okay. So can we get an empty packet? Not really. It's kind of a bag. Oh, okay. Who looks at measure transform now? I don't think anybody does. Okay. Well, this does. I'm going to look here. Packet.tunes, packet.measure transform. Okay. Yeah, I think we can take that out of here. All right, so let's see report. He does code for with quantizer. Oh, and he does tune. I believe we could just do tune.notes here, because our quantizer already made that decision and built new tunes. In here, the mapping built a new one, and I think I'm just going to use the $0 since it's the only use of it. Okay, so it built a new tune with that map applied. So I believe we can take it out of our usage here. Okay, so this should still pass tests. And I think in effect it was being applied twice. But quantizing by coordinates and then repeating it is neutral. All right, but we don't need this anymore. Yeah, I guess that's... right. Should be some tests. No. Code for... Okay, now this thing... Oh, he's being used in report. Okay, what's report doing with the quantizer? I don't think he's using it. Somebody calling it should. Okay, now there's no use of quantizer in there, so let's take it out of here. Okay, so we return new packet with title and output. Okay. All right, so do we have quantizer anywhere in Parsons Code report? I guess we look for the word measure. No. Okay, I'm not seeing anything passed in here. Okay. Now code 4 is looking a lot more simple, right? Let's inline this stuff. I don't think it's obnoxious. Encoder is always a new Parsons code. Analyze, tune.notes. All these had more complexity a few minutes ago. But that... Okay. Remove transform from Parsons code report. Okay, so we've simplified that thing. Been a rough day this way, but I think we're getting there. Okay, now I don't think anybody's looking in the packet for that thing anymore, so let's confirm that. Okay, if I delete this, well, I'm going to get complaints. Any references? I guess that's the first thing. Only in packet. Okay, so I'm going to delete it. Well, can I delete it from these first? Let's do that. Okay, there's measure transform, measure transform. Clearly you can't do it if it's not there. And same thing here. And I guess there's not enough going on. I can just delete this. Okay. Somebody's going to complain, I hope. All right. ParsonsCodeView. Creates a packet with no argument there. That's fine. Okay. Measure transform. Tunes map tune. Okay, packet doesn't get this anymore. Right, and so the quantizer transform turns tunes into the new tunes. That's good. All right, there may be a few tests now that showed it. But okay, no. All right, remove measure transform from packet. Okay, I'm happy to have packet simplified. It's kind of a hack. I couldn't get the types worked out on those pipelines, you know, inputs to outputs, and are they all compatible? All right, that's getting there. Okay, now this, I would like an initializer that does this. Where's packet? Well, it's really a convenience init. No parameters, and we're going to call self.init this with Okay, this is really the only place using it, but I think it's enough. Okay, so this becomes just packet. Okay, so I think what's going on, I want to move these up. Text input quantizer source. Is that the only three? Text input to quantizer to source. Okay, yeah. And then I want to make an array of those. Text input quantizer source. Can I do that? I'm back to my pipeline stuff. Okay. What's your type? Transforms. They're all calling transform. Okay, so this is, I believe I can do this. I can say pipeline dot reduce, and I always forget these things. It's next partial result. So result is the type. So that's going to be our packet. And then this is, I'll type it again so I can get my pipeline at reduce. Result transform produces result. Okay, so given a packet, we're going to return transform of packet. Packet, excuse me. Okay, and I think that replaces these 4 lines. All right, so we create our pipeline, we pass packet, an empty packet, and then we successively apply transform on each one of those. Okay, and the return should be implicit, so I think that should be okay like that. Okay, and we'll run it. Okay, and X1, DD, KE, just to mix it up, A, B, C, D, D, C, B, A, E, F, G, A. Okay, and that should be fine. Quantized. Where that button decided to activate. Yeah, whatever. All right, fewer nodes. It should be 6, right? 3, 6. Okay, so that's doing its thing. Okay, now, why does he need all this stuff? He needs it because all these pipelines, to create these pipelines, it needs it. but they should kind of be static. Okay. I'm not sure the next move here. Well, we pass the source in when we create the Parsons code view. Let's check the preview just for grins. Okay. Parsons code view. That's the button. The text isn't showing up. All right. What I think should happen. Well, in the whole app, I think this should be the step that does the work. So I think the report stuff, I think it's on the wrong thing. Now, the only thing I could think, the thing I think it maybe should do, it could tell us that we could set the title in there. Would make sense, but I think we can pull this out first and then deal with that. Okay, so what I'm trying to do is move this method over to the run button here. All right, so I'm gonna if I somehow created the pipeline outside, right, then this stuff would definitely get simpler. Okay, and let's look at the button. Generate report, action, do it. Okay. Button style bordered prominent. All right, and then our other view is, okay, so where are we on the to-dos? Make quantizer apply its rules. Yes. Make remove measure transform from packet. Okay. That is here. This is all about the pipeline still. Okay, figure out text input sync. No, I think, let's see, delete source and sync, we did those too. All right, so move action code to the final stage rather than Parsons code report. Now if I'm just passing the buck in, all right, let's take, okay, we'll need that, we'll need that. Don't think we need, do we need that? No. That's the transform, okay. I think we're done looking at those for now. Okay, content view, okay. Content view doesn't like creating those. Okay, it's got the tune, the quantizer setting. Parsons code view gets everything passed in, and then text output view. I almost want to split that up. But maybe what I do is Let's pass this stuff in first and get this method moved over. Okay, ParsonsCodeView. He's got his do it method. I'm going to copy that out. Put it in TextOutputView. Okay. I'll just put the method here. Body, top line, button, run. Let's compare that to this. Top line, button, action, do it. Yeah, let's take this much. Instead of button run that, we're going to action do it with button style and drop that, and this becomes run. Okay, yeah, we don't have all those variables coming in. Ugh, I don't think we should need them. Well, let's pass them in for now and then pull them out as we get straightened out. Okay, so it needs all these. Variables. Okay, got all those pieces. Content view probably doesn't have all that stuff. It could be the same as preview. Okay, let's open notes again. Okay. Come on, Apple. Okay, quantize. Let's do 1/2. Generate report should still work. That looks good. Okay. Run. I don't know what it's going to do. Okay. Huh. Interesting. Okay. What is this doing? Do it. Okay, we got the text input, the quantizer, source. Is different. Over here, source was the Parsons code transform, and it was passed in the constructor of ParsonsCodeView. Parsons code report. So this thing. Ooh. Heterogeneous port transform. No, something's wrong. Doesn't he need variables? Text input source. Those things. Parsons code transform writes the report in there. And this is boring. Okay. And there's packet. Heterogeneous collection literal. Why is this heterogeneous? Text input source is a transform. Parsons code report transform should be a transform. Reduce. No, we want the other reduce. No, that's not right. All right, when in doubt, throw away the build and make it try again. Heterogeneous collection can only be inferred to any. I don't understand. This thing. Well, I don't think this shouldn't matter unless I have some sort of duplicate variable somewhere, which is possible. Type should be transform. Okay. Why are these guys acceptable that way? That's really kind of weird. They do have actual constructors, so maybe it's something with that. Text input source. It must be something about having a constructor that lets it know that the type is that, I guess. Okay. But anyway. Okay, so does this work? Where's no scaling? Do I still have that there? No. Okay, that's two measures. Let's quantize them at a quarter. Thank you. And run. Okay. That was 2 8 measures. 1, 2, 3, 4, 5, 6, 7, 8. Okay. If I quantize to a half. Okay. All right. So we've moved. I could find a better word for that, but okay. So I'm going to take this. Well, let's capture what we've got. We moved to it from ParsonsCodeView to TextOutputView. Okay. And now I want to get this do it out of here. Okay, so I'm going to take this away. I'm going to take the button away. I think I pretty much have to. I can put an empty text there for now. Okay. And okay, that should just run, should look okay, and then we can see what we can get rid of. Okay. Yeah, title. It would be nice to have something in there. Let's just put Parsons Code Report. And then run. Good. Okay. Now, Parsons Code View, like, does it ever reference this? Parsons Code View. Only here. Okay. So I don't think I need input. I don't need should quantize. I don't need numerator denominator. And I don't need any of this stuff, which makes sense. There's nothing going on this screen. Right? We've eliminated it all. Okay. It knows its source, I think, is okay. Yeah, it needs that. Okay, so in here, this stuff, keep the source, but the rest of this junk goes. Okay. then content view created a Parsons code view. Doesn't need all this stuff. Okay. It should test and run. Okay, and now let's run it. I should default this to the input. Key of G, ABC, above, ABAC, ABFA, GGAB. Invisible spot. Okay, that should reduce it. Yep. Okay. We've eliminated unused bindings from Parsons code view. Okay, now I want to get this stuff. It needs its source. We're not using these really. Well, we are here. Do we pass them in? We do. Okay. Then why don't we need Parsons code report? Oh, they are all up there. Okay. He doesn't need any arguments, so he's okay. And then text output sync doesn't really do anything transformation wise. Okay, so sorry, content view. Let's get that out of the way too. All right, now I'm going to update that in here. I don't think text output cares. Pipeline is these things. All right, now I want to pass that to this thing. Maybe text output isn't even in the pipeline. We're using it as a sink and not transforming through it. Okay, so if text output view took a pipeline, and I don't think it's even changing at this point, so text output view, let's go in there, and he doesn't need an init. Okay. Okay, and then pipeline. don't think we need that. Okay, does that build? Text output view. Oh, that went away. Okay, good. All right, I think I haven't changed anything yet. QG, ABCD. All right, I run. That's fine. Now I want to run through the pipeline instead of through the other text output view. Right. Okay, so where's do it? Okay, pipeline is coming in, so now I don't need to do it there. Okay. Well, I don't see where quantizer is used either. Well, really, I almost can get rid of these three, right? Okay, does this work? Let's find no scale. No. Okay. Too big a step. Let's break here. Let's break here and look at the pipeline. No scan. Okay. All right. So I want to look at self and his pipeline. Has 3 values. Text input source. So this is looking plausible. Bindings and so on. Okay. Let's see if we can print self.pipeline sub 0. I don't know if it really gets one. It's a function, right? Oh no, it's a transform. Okay. I mean, it's got some stuff, and then it's got some other stuff. Okay, text input source. Let's do that. Self to pipeline sub 0 dot transform packet. Self.pipeline sub 0 is okay. Dot input self dot text input source. Let's see this thing. as a text input source dot input. What's up? Yeah, I can't get to that name, to that item. Well, it does have input there, right? With guts. Okay, so if this thing, let's go back where we got that unknown printed out. If the result of transforming with the text input source is no values, because it's supposed to consult. Well, that's the transform. It's producing no values, so it's like it's an empty transform. Don't understand that. Okay, let's make sure we're looking at the right ones. Well, can tell we're going to pick up there tomorrow. All right. So text input is a text input source linked to $input with this warning that it will result in a constant binding, and that seems bad. Okay. I feel like maybe what we have to do is reverse the objects and like who's in charge. I think the pipeline stage needs to own the contents. Okay, so yields empty packet. And this is the content view pipeline. Okay. And I guess the question is, does the stage, well, I guess we're calling it transform. Does the transform need to be an observed object? Okay. I think that's what we need to get rid of that warning. So we'll explore that tomorrow. But we made some dents today. I think we've well, one thing is we got ParsonsCodeView out of the business of applying all the transformations and all that stuff. So I think that's a good step. We almost have a pipeline. We have a pipeline, it just isn't being used. But I feel like if this worked, all of a sudden a lot of inputs to our output view should go away, because most of these are there. Well, all this stuff is for the benefit of computing the packet, and it should get a packet that, I guess we might pass title, output, and errors, but the others, they're not the business of this thing. So I think we're okay there, and that'll go away and simplify that a bit. So I feel like we're kind of on a track that will do something, and we're getting this pipeline is much more close to being a domain object, which is what I want it to be. It's kind of in this pipeline domain, but it's a thing that you give it packets, and it gives you back the resulting packet from the pipeline, which is another transform. Okay, worth noting. So I think we'll pick up there tomorrow. Tomorrow is, oh no, it's next week now. So Monday, 2, 3, 4, 5, Monday the 5th, we'll pick up there 1 to 3:30 p.m. Eastern Standard Time, or 6 to 8:30 p.m. UTC. Also, check out xp123.com. I got a new blog up today, so take a look. All right, thanks for joining. Catch you next time. Bye-bye.